Hello and welcome to ECMath. Today we're going to look at graphing polar functions both on your calculator and then by hand. This is the function we're going to graph, r equals 4 sine 2 theta. Now if you try to put this in right here, you will notice you're in y equals mode when not r equals mode. So you need to get into r equals mode by pressing mode. Then you will scroll down, double check that radian is selected, scroll down one more, click over until you get POL, that's polar. Polar mode is now engaged. If you need to return to function mode, scroll over and select function. But we want to be in polar mode, so we're going to go back and press y equals. Look, the r's have now changed, or the y's have now changed to r's. So let's type in our function, 4 sine 2 theta. Where's theta? Oh, it's right here, this xt theta n button. When you press that in polar mode, gives you a theta. Close your parentheses. Let's just double check that all of our graphs come out okay. All right, that's a polar graph, but we could definitely do a lot better. And when we graph it by hand, we're going to need some more precision than this. So let's play around with some settings. First, one thing that you may want to do is go to your zoom and pick zoom square. That's just going to counteract the rectangular nature of your screen and make it so that your x ticks and y ticks are the same amount. So this looks a little more symmetric, a little better as a polar graph. And we might even want to zoom in, so we can go zoom to, zoom in, then you click the center. Okay, we maybe went too much, but we're starting to see what polar graph we're expecting. I'd also like to show you one feature of your polar graph, which is if you go window right now, you have 3 additional options. You have theta min and theta max. That's set to 0 to 2 pi. The idea in polar is you can go around a circle as many times as you want. So say that we set our theta max to only pi instead of 2 pi. Then this is only graphing half a circle. It switches to decimal. That only graphs half of the polar curve. So if you're not seeing an entire polar curve, you may want to double check that your theta min and theta max are 0 to 2 pi, or even greater. Some polar curves need more than 2 pi. They need 4 pi or 8 pi or 10 pi. So there's our curve back. Another thing that you may want to check if you're getting a polar curve that looks a little wonky is that your theta step is set to something appropriate. Let me just, for example, change my theta step to 1. Theta step is how frequently it plots points as it goes around. So for example, this is plotting points every 1 radians and then connecting the dots. And you will see that it does not do a very good job. If you get ugly junk like that, consider changing your theta step to something smaller. Here's 0.5. Still pretty ugly. Let's change that theta step back down to something like it was 0.1, and you get a smoother curve. Polar curves are almost always curves, not jagged mountains. So make sure your theta step is set correctly. Okay, so that's a polar graph on your calculator. You're done. Except if I wanted you to graph this by hand, I would be looking for specific point values. So how do we get those? Well, we go to the table. So if we go to our table, we're doing second graph to access the table. We can then see the radius value for specific angles theta. Right now, this is theta 1, 2, 3, 4, 5, 6 radians, not pi. That's just 1, 2, 3, 4, 5, 6. That's no good. So we need to set up our table correctly to have the right change in radian values. And the way we do that is we go second window to table set, right? Table set, so second window, there it is. And it's going to go table setup. We're going to change that delta table to a small number. Now, don't just pick any random number. What you're going to do is pick the number that matches with what the smallest item on your polar graph that you have is. And this one, the smallest item on our polar graph is pi over 12. Excuse me, I'm doing this with a mouse. That's why my handwriting's so bad. We have a pi over 12. That's because this is pi, and we got 12 total markings from 0 to pi over 12. So we need to set our delta table to be pi divided by 12. We don't usually use pi over 12s, except when we're in polar. If you're doing just a quick polar table, you can also set your delta table to pi over 6. And what that will do is give you values for every other tick mark. However, for the graph that we're doing today, we actually need the pi over 12s. We need all the possible information. So we set our delta table to pi over 12, 0.26. We also need to double check our table start is set to 0. Here, let me show you. If this is set to something like 0.5, and we go back to table, it's all messed up because it's starting at 0.5 and then adding pi over 12 each time. This is no good. So in your table set, make sure your table starts at 0, and your delta table is either pi over 12 or pi over 6 if you're feeling lazy. Okay, now we can go back to the table, and you'll see all of these wonderful values. These are the radian values: pi over 12, pi over 6, pi over 4, pi over 3, and etc. And these are the radius values at those points. All you have to do from here is plot at every angle that radius. So at angle 0, I'm going to plot the radius 0. Let me get a larger pen slightly. We'll do a festive color. Go. At pi over 12, I'm going to plot a 0.26. So that's pretty small. Okay, we'll just estimate. At the next one, oh, I'm sorry, 0.26 is the pi over 12. At pi over 12, I'm going to plot 2. Well, that's embarrassing. At pi over 12, we're going to plot 2. At pi over 6, we're going to plot 3.46. We just do 3.4. At the next one, we're going to plot 4. So this is our pi over 4. We do 1, 2, 3, 4. Then we're back to 3.46. Then we're back to 2. And then we're back to 0. And we saw what the graph looked like earlier. This is creating that first petal of our flower graph. Now, here's something I think is pretty cool with polar. You might expect the next petal to be maybe this one over here, because like order of quadrants, but it's not. Let's keep scrolling and take a look. So we got back to 1.57, that's our pi over 2. So let's scroll down until that is just off the page. Okay, here we can see pi over 2 right at the top, and here we can see pi at the bottom. So we're gonna get some values here. But look what happens in this next quadrant. We're graphing negative radii. So at our next piece, this is our next pi over 12 right here. We're going to graph the radius of -2, which is going to be here. Remember, when we have a negative radius, you graph in the opposite direction of the angle. And all of these are going to be negative. So we're actually going to end up graphing in this quadrant. We go to the next angle here, and we graph the -3.5 value. 1, 2, 3, -3.5. Here we graph a -4, back to -5, back to our -2, and then back to 0 when we're at pi. So when we're at pi, we're back to 0. And so this has plotted the second petal of the rose curve, but even though it's the second petal, it's plotting it in that quadrant 4. Let's do the next quadrant. I'm going to stop narrating so we can speed this up a little bit. We'll just plot the points. And then our last quadrant, we, again, are starting at, goofy radians. Just keep counting, keep track. If you lose track of where you're at, it's easy to figure out where pi is because we know what 3.14 is, and then you can just count down, the number of rows. So we're at 3.14, we counted 1, 2, 3, 4, 5, 6 more. Also, we got back to 0, so that's a good place to look for. So we're gonna got that 0s at the top. And then we're graphing quadrant 4 angles, but we're graphing negative radii, which is going to graph shapes in quadrant 2. All right, and it's got those same values that we had before. Another thing that you might notice is right here, it says -8e -13. Okay, sometimes this is a thing your calculator will do. You need to know what this is, because some people will be like, what is this? This is the same as -8 times 10 to the -13. Hey, what's that? Approximately? That's 0. That's the congruence sign. Approximately, that is 0. This is your calculator's way of telling you 0. So we should indeed connect back to 0 here. Don't get fancy with something else. It's just doing some approximation. Okay, that's how you graph a polar curve by hand using the table feature on your calculator. It's a little bit tedious, but honestly, it's not that hard. And if you set your table to pi over 12, you're able to just copy in all the values and get all sorts of curves, rose curves, spiral curves, whatever. And then you do need to be able to plot all the points, but you can check your work by just going to the graph. And hey, looks like we did a pretty good job. Thank you for watching, folks. This is a Mr. X signing off. I'll see you all next time.